لا يا اما لا. اوكي.
Yes.
وين كنا وصلنا؟ مش في الماضي. Transfer equation. Okay, this is application. Solve numerically the simplified transient unidirectional heat transfer equation using the explicit finite differences scheme. Okay, one can give dt over d small t equal alpha d square t over dx square tj0 equal tan equal t0 t0n equal t1. هلا this one is the initial condition, okay, and this two temperatures are the boundary conditions. مفهوم? And this equation is a simplified heat transfer equation, unidirectional equation, and alpha is lambda over rho Cp, is a thermal diffusivity in meter square second minus 1. مفهوم? Then what can I do? Do you see what we have here? I need to scheme dt over d small t using the right scheming, okay? And this method is a explicit finite difference method, okay? And I said that this method is when we express Tn plus 1 equal function of Tn. Then Tn plus 1 function of Tn, okay? Then for the time is a right scheming. Tjn plus 1 minus Tjn over delta T. Okay? Is a right scheming a long time because the time is growing up. Then we go to the right. Now alpha is constant, and if I need to discrete d square t over dx square, I use now a formula along x. Now ti plus 1n minus tin plus ti minus 1n over delta x square. Okay, now it's a formula. Okay, you can use it fast.
دكتور في هشام بده يفوت.
Okay. Then now the equation is schemed using the explicit finite difference method. Then, and we have n plus 1 function of n. Do you see n plus 1 function of n? Then I need to extract tin plus 1 function of the other terms, which are known terms, because at time 0 here, I can determine the time 1. And by knowing time 1, I can determine time 2 and the following. مفهوم? Then tin plus 1 or tjn plus 1 equal a delta t over delta x square, tj plus 1 n plus tj minus 1 n plus 1 minus 2a alpha delta t over delta x square tjn. Okay, حطينا طلعنا tjn plus 1 function of the other temperatures. Now I consider a delta t over delta x square m. Then this one is m, and this one is m. And I can write tjn plus 1 equal mtj plus 1n plus tj minus 1n plus 1 minus 2m tjn. Okay?
دكتور في حدا فينا بده يفوت بليز.
Okay. How this method can be realized? Look, I know the time, all the temperature at time 0. مفهوم? And I know the boundary condition when x equals 0, and this one it can be x max, yani I max, j max on j max. Okay, it's equal to a. Then if I put here, we have n plus 1. If I put in place of n 0, what I have تبعوني مظبوط. Okay, tj1 equal j plus 1 n بتصير tj plus 1 0, j minus 1 n تطلع tj minus 1 0, tjn equal tg 0. Then tj 0, tj plus 1 0, tj minus 1 0 is equal to t0. It's equal to t0. Here is t0 because whatever j, and at time 0 we have t0. Then this is t0, this is t0, and this is t0. Then 2m t0 plus 1 minus 2m t0, I obtain t0. Whatever j going from, بدي أعرف from what to what j. هون انتبهوا له. J is going from which value? If I put here j0, here j0, شو بيطلع معي هون؟ 1. And here minus 1. بما انه انا طلع لي minus 1, I'm out of domain. Then 0 cannot be worked. Then I need to change j to 1. J equal 1. Here is 2. Here is 0. And here is 1. Then from the cell T10, T10 هيدي هون بتصير الواي وهيدي التي، يعني الاكس، هيدي الاكس وهيدي التي، هيدي الجي اكس جي. T10 وين ال10 هيدي from this point from this point here T10. From T10 I have T20. T20 to T0 هيدي T10 to T0. لحظة، أنا I need to calculate. لحظة خليكم معي بس to clean. Okay. I need to calculate T1 هيدي هون 1 T11 from to T0 to 0 0 and 2 1 0. مفهوم بعدكم معي؟
Yes.
Okay. I go back. I clean. Then I need 2 1 1 2 1 1 هيدي 1 هون وهيدي 1 هون. 2 1 1 this point لا. I need this point لا. This point here. I need this point. From this point T11. Okay, what we have? we have T20, T00, T10. 200 this point here, 210 this point here, and 220 temperature 20 is here. From these 3 points, which are known points, okay, from the initial condition 0, هذه هون initial condition at time 0. ما هيك؟ هذه initial condition هون. From the initial condition, I determine this point here. شفتوها؟ Now I need to determine this point here. This point here is T21. T21. Then I need T30, T10, T20, 1, 2, 3. I need. Then from 20 here, 30 here, and 00, 10, 20, 30 is here. 30 is here. Then from this one, I determine this point here. And then the following, from these 3 points, I determine this point. From these 3 points, I determine this point. From these 3 points, I determine this one. From these 3 points, I determine this one. From these 3 points, I determine this one. شفتوا?
Yeah.
Then this one is 1 T1 1, and this one T J max minus 1 1. J max minus 1 1. طلعوا. لكن قلت لكم 0 ما بتزبط. ليش؟ لأنه هون we have minus 1 out of domain. Okay? If I replace here J max in place of J max 1. Here, then J max plus 1, 0. J max plus 1 out of domain. Then I cannot replace J per J max. I need to replace it by J max minus 1. In this case, I have J max here, J max minus 2 here, J max minus 2 here, and J max here. مفهوم? Then from these 3 points, J max minus 1, J max minus 2, 0, I determine J max minus 1, 1. Then, تبقوا منيح. T01, this point here, T01, this point here, it can be determined from what? From the boundary condition T0, N, whatever N, we have T1. Then here, all these points here are T1. And all the points here are T0. Then this line here and this line here are determined from the boundary conditions. مفهوم? And from the calculation, I can determine all these points. شفتوهم كيف بيشتغل الكمبيوتر؟
Yeah.
Do you understand?
Yes.
Good. Then it's like this, and the computer can determine all the points of the domain. But we determine these points, and the method converge to a fixed values. But does these values or do these values are correct or not? But here we have Tjn plus 1 is positive. M is a constant positive, and this term is positive. The temperature here is positive. This term here must be positive. In order to determine the stability of our system, this term here must be positive. Okay? Then we do the stability study. 1 minus 2m, yani 1 minus 2 alpha delta t over delta x square must be positive, bigger or equal to 0. Then delta t lower or equal to delta x square over 2a. Okay? هلا بيقولوا لنا we have a system of lengths L equal 10 centimeter, يعني 0.1 meter. We need to decompose this lengths on n step, 100 step. يعني x is equal, must be equal, يعني j of x هون أنا سميته j must be equal j max is equal to 100. Then x max equal j max delta x. Then delta x is equal 0.1, لأنه هذه هي الx max over 100. Then delta x equal 0.001 meter. هيدا step of x، يعني هيدا قطعته أنا 100 step of delta x. Each step is equal to delta x. By knowing the dimension of the system delta x, then one can determine the time step delta t by knowing this one, 0.001 square over 2 alpha 0.025 meter square per second. Then I can determine delta t mean minimum. يعني هلا شو بيصير معي؟ أنا جبت الدلتا تي minimum. Okay, طلعوا. If delta t is bigger than this value, then is very big, then I will see a curve like this. Like this. Then we have a non-stability here. If delta t is a little bit equal to this value, then I will see a curve like this. Non-stable curve. If delta t is small than this value, then I can find a curve like this. مفهوم؟ يعني there is no perturbation in the curve. Then the stability study give me a smoothing curve, an unperturbed curve. مفهوم؟
مفهوم.
This method is not stable, but it is convergent method. Whatever the initial profile, then the stability study is required, and a good initial profile must be used. Good initial profile. لازم يكون الانيشال boundary condition are true to get the true values. Okay? مفهوم? By knowing the text from the physical dimension of our domain, one can easily determine delta t. Then the stability mode is considered when delta t is smaller than delta t max. Delta t max is equal to delta x square over 2 alpha. مفهوم؟
Yes.
Okay, good. Flow chart and the program of resolution. تعرفوا الفلو chart متعلمينه ما هيك؟
أكيد.
From the beginning, the begin, end. Begin, end. Then we enter to the program the boundary condition and the initial condition T0 T1 and the value M يعني هي ال A delta T يلي هي M A delta T over delta X square delta T over delta X square. Then يعني أنا بندخل الألفا diffusivity يعني 0.25 مثلا أو 0.25 delta T step 0.1 مثلا delta X 0.001 for example بندخلهم. We determine M equal A times delta T over delta X power 2 بندخلهم. I give N a value N, a big value which is 100. Then I initialize my temperature. I give T00 is equal to 0. I initialize the vector and the matrix. Okay, the matrix T temperature. Then from I or J, he is it, going from 1 to I max يعني. I max equal to N, 2 times N, I max. انتوا بتحددوها هيدي الاي ماكس ده شني قايل لكم بدخلوها. Then I determine the initial Ti0 equal T0 is the initial condition here. Here is the initial condition. Then for J equal J and the time going from 1 to 200 around 200. Okay. I determine here the boundary condition. Boundary condition يعني T0 J equal T1 هذا J كله J هيدي هون و T2 2 times N J equal to 0. هودي الباوندري كونديشن اللي اعطونا اياها. بيرجع from J time يعني going from 1 على طول اللوب تايم لوب بتكون هي اكبر لوب وبقلب منها بيكونوا الاكس لوب والواي لوب. مفهوم؟ التايم لوب تاخدوها لانه على طول هي اكبر لوب. الاول لوب بناخدها وهوديك بقلبها. هون جي 1 لل 199 والجي 1 to J max يعني هون. I write what? I write the scheming, the explicit finite difference scheme of the temperature يعني T I J هون بده يطلع MT I plus 1 J minus 1 plus T J minus 1 يعني كله J يعني J minus 1 J minus 1 plus 1 minus 2M T J minus 1 IJ sorry IJ. أنا مني شايفهم صغار إنه عندي مش مبينين واضحين. أوكي أنتوا بتكبروا الصورة بتشوفوها. Good like this. Okay, this is the scheming, the explicit finite difference scheme of the temperature. Then we write it and we do 2 loops. Loop for the x-axis, loop for time. Then we determine all the temperature, and with the initial boundary condition, we find here the temperature, the final temperature in all the nodes, in all nodes. مفهوم؟ هلا. For the program, CLC clear, N max equal input N max, I max input I max, T0 equal 298.15 و T1 300.15. If we have to 282 هلا هون اخدينا اخدين T1. اذا بدكم فيكم تاخذوا T2 اذا ما بدكم ما بتاخذوها. A alpha يعني equal 0.25 dx equal 0.05 dt is equal dt. هلا بحطنا فيني انا حتى value constant value dt وفيني اقول انا dt هي dx times dx over 2a و 2a يعني بياخذ المينيمم الماكسيموم dt max بياخذ والr يلي هي الام الr equal a times dt over dx times dx square. يعني انا باخذ dt minus epsilon باخذها. اوكي dt max minus epsilon. for اول لوب هيدي for I equal 1 to point I max plus 1. اوكي بلاش من 1 Ti1 equal T0 and هيدي اللوب بيرجع for n equal 1 to n max double point n max T1n equal T1 و Ti max plus 1 n equal T2. انا بضطر اعدل انه هون الماتلاب ما بيفهم الزيرو مفهوم؟ بعدكم معي؟ الماتلاب ما بيفهم الزيرو بالفيكتورز.
Yes.
اوكي؟ انا مضطر محل زيرو حط 1 وبدل ما اوقف على الاي ماكس بدي اوقف على الاي ماكس بلس 1. اوكي؟ ده هيك بنعدل اند بنحط for n equal 1 to double point n max t1 n equal t1 point comma semicolon يعني ti max plus 1 n equals t2 semicolon and for n equal 1 double point n max for I equal 2 double point I max ti n plus 1 equal بتحطوا الايكويشن كلها انا اياها and بنحط f print f يا اما بنحط t يا اما بنحط بلوت اللي بدكم اياه. هذا هو البروجرام for the explicit method. مفهوم؟
مفهوم.
good. هلا انا عامل هون انا بالمانuscript اللي بعت لكم اياها عامل لكم الابلكيشن in 2D heat transfer equation. in 2D heat transfer equation عامل لكم الابلكيشن فيكم تشوفوها واضحه كثير. اوكي؟ واضحه بس انا بدي اشتغل الابلكيشن ثاني ما فيني اشتغل كل الابلكيشنز تبعونا. بدي انتقل للويف ايكويشن لما تاخذ وقت معي خليني اعملها اليوم اضبط. اوكي؟
في حدا بالويتنج روم بليز.
اوكي مفهوم؟
Yes.
لكن 2D heat transfer equation you have it. Okay. Yesterday I sent you all the pages of this chapter. Okay. On WhatsApp. Okay, you have it in WhatsApp. Then you can download it, and I think only we have time to finish this very nice and very important application on the wave equation, which is called the elliptical form. Elliptical form. إنه إحنا كنا عم نشتغل parabolic form or hyperbolic form. Here is the elliptical form, another kind. Okay. Why? Because in the heat transfer equation we have dt over d small t, but here we have d square over dt square. Double differentiation a long time. Okay, we need to know how can we solve this double differentiation a long time. Okay.
دكتور في اثنين بعد بدهم يفوتوا عمر معروف.
Okay. Good. كلكم انت تنحل سوا هيدي الايكويشن to solve this equation.
هايل.
Okay, because is not complicated, but we have a hierarchy in the calculation. Then we need to know which one is the first and which one is the second and هلا بده يطفي يعني بس خلينا جود.
انت اعمل بوز مش اكثر.
شير سكرين بس تعمل انقطع الكهرباء عندي انا. اوكي جود. منيح ما بلشنا فيه على كل حال. اوكي like this. Then there is the wave equation that propagates in a wall. and it is written as d square psi over dt square minus c delta psi equal f x y t. F is a function of x, y, and t time. C is a light celerity. Okay, is a light velocity, is a light 3 times 10 power 8. Okay, then they will give us the initial condition. Here, because we have dt square, we have two initial conditions. We have initial condition at the psi minus 1, ij equals 0, whatever I and j, and at the psi ij 0 equals 0, because we have dt square. Okay, then we have double initial conditions. And this initial condition at the interior of the domain mu 0, whatever I is going from 0 to I max, and j is going from 0 to j max. Mu 0 look at this picture here. Mu 0 is inside of the domain. Mu 1 is this borders, mu 1. Mu 2 is the down border, and mu 3 is the upper border. Okay? Then, initial conditions at mu 0. Boundary condition now. Boundary condition, we have d psi over dy equals 0. Okay, d psi over dy equals 0, which is called Dirichlet condition. Dirichlet condition because it's a adiabatic, which is adiabatic of waves. There is no wave that is going out or enter from outside to inside on mu2. وين mu2 عند هيدي. لكن هون مثل كأننا جينا حطينا فلين او حطينا نشارة خشب. شو بيحطوا للصوت؟ نشارة خشب هون. ما في من الصوت يفوت من جوا من برا لجوا ولا من جوا لبرا. مفهوم؟ هيدي الكونديشن d psi over dy equals 0, which is called Dirichlet condition. And then we applied Summerfield condition on mu1 and the mu3. mu1 he d psi over dt plus c d psi over dx equals 0 on mu1, or d psi over dt plus c d psi over dy equals 0 on mu3. when هيدي mu1 على هودي الاثنين along x وmu3 along y. دايك على mu3 حطيناها along y وهذيك على mu1 along x. هن عاطينا اياهن، يعني عاطينا initial condition، عاطينا Dirichlet condition، وعاطينا Summerfield condition. من دون